Yes, yeah, yeah. It is being recorded now. Yeah. So, what happened? The first thing we did was that we changed the UN to in X, so it can become f of x is equals to 1 plus x. Everything was square rooted. Yeah, square rooted. Yeah. So when you do that, the first thing you have to first find the domain function of what you've been given, and we had to change the square root to power of 1 over x. Sorry, 1 over 2, because we all know when it's a square root there, this square root is like equals to the power half. That we all know. Yeah. So what happens is from here.
Oh, just a minute.
Yes.
Can't hear what you're saying.
Can't hear what I'm saying. Huh? Can you hear me now?
Safe man and then nice, but it's say some kuma. Sagamba. Bueno, estamos hablando de sagamba, ¿eh? Kushimika. Kushimika.
Do your mic is on.
Okay, perfect. I hope you guys can hear me now. Yeah, as I said, what I said last week is the same thing I'm saying now. The first thing you do is you have to change everything so that it should be in function of x. So what's the first thing you do? You've been given an equation. They gave you square root of 1 plus un. That un should change to x. That means your whole thing will change from it being 1 plus un to it being 1 plus x. What happens from there? You now move. The second step now is to simplify what you've been given, your equation. How do you simplify the square root of 1 plus x?
Mono, what are we doing?
We're looking at the example I gave you last time.
Come here real quick.
What? Yeah, so as I say, the first thing is you have to change everything to be in function of x. I've mentioned, I don't know how many times I'm going to say that. Yeah, this is what we did on Tuesday. This example we did on Tuesday. Yeah, so this is I actually sent you guys this part, so I'm just roughly going through so that you can at least remember. Yeah, so the first thing we did is change everything so it can be in function of x. When you do that, you simplify your equation so that it can become 1 plus x. Everything should be to the power half. We know why it's to the power half, because you know that the square root is also equals to it being the power of half. That we know. After you simplify what you've been given, you only get what is in your square root. At times, the question won't be the square root of something. At times, they can just give you let's see, they can just give you 3un plus 4un. Then you solve that. In this case here, it was square rooted. So you get what's inside your square root, which is 1 plus x. That 1 plus x, find the domain function of the 1 plus x. What do? Find the value of x. There you have 1 plus x is greater or equals to 0. What do you do from there? The 1 goes to the other side. We're trying to find the value of x. What value of x do you find? -1. So there, what happens is you now find the domain function of the square root of 1 plus x, which has been simplified to x being greater or equals to -1. That is what you have, this part here at the end here. So this is what you actually use to find the domain function. So since our x here is greater or equal to -1, what do you know? What do you know from here? It means our starting point there is -1. Where will it end? We don't know what value x is, so that goes up to infinity. That's why it's infinity there. Yeah, that's how it is there. Yeah. Then yeah. Then we know that. Yeah.
What was the question for this example which you are giving? The question.
Was to study the sweets.
Okay.
Yeah. So let's say they give you you are in analysis exam and they give you on the paper, they say study the sweets. This is how you study a sweets. Yeah. I mentioned this on Tuesday. So yeah. So the question, Oyo, is to study the sweets. And this is how you study a sweet in this nature. Yeah. So after you find the value of x, you use the value of x to find your domain function, which we did. We found our domain function there. After you find the domain function, you go back to the initial equation you were given, which is square root of 1 plus x. You get the square root of 1 plus x and you differentiate it. When you differentiate the square root of 1 plus x, what you find? -half over square root of 1 plus x. When you solve, you will find that. Yeah. And then from there, I asked you guys to now apply what we did in the coup. For you guys now further study the sweets. The first part, everything here you're doing is basically simplification of the sweets, so that as you are going to apply what you were given, what I explained in the coup, yeah, so you can apply everything there here. So when you find your domain function, you're going to use that domain function as you are trying to bring out points and bring out whatever it is and all that. So the first thing you do, as usual, is, as usual, since this whole thing is in function of x, so what they're going to do. So first and foremost, you have to first summarize. Oh, okay, thank you. Okay. Yeah, okay. So what do you do after this point here? After this point here, what's the next thing you do? The next thing you do is you now have to look at what you've been given here. What's your domain function? Then from your domain function, you'll now be able to know if what you've been given is croissant, decroissant, name it, whatever it is. So your domain function is going to sell you out. It will help you note down what you've been given. When you look at our domain function, we found, since our x value there is -1, so starting point there was -1, because it says greater or equals to. What's after -1? You have a 0. That's why when you look at the next domain function there, where it says a and b.
Mono,
0.
before you go any further, I've got a question. On
Yeah.
this, I don't know if it's 1/2, open brackets, 1 plus x over square root of 1 plus x. And then it was equals to 1/2 square root 1 plus x. How did you find that? How did you simplify all that? I'm lost on that part.
So what we were given is let me do this. Move this here. So what we're given is f of x, right, is equals to square root of 1 plus x. Eh? So this is actually the same thing as writing open bracket 1 plus x, everything to the power half. The same thing here. So then from there, what do? You get this, you have to differentiate this. How do you differentiate this? There are different ways of differentiating this. So one of the first things, we all know how to differentiate. When you be given the power, what happens? The power becomes a whole number, you multiply it, then the power -1. That's what you do. That's how you differentiate. So we'll say f of x I'll say f prime x, this means differentiating is going to be equals to, so this power comes in front, differentiating. I don't know whether you guys remember how to differentiate. So remember, the power always comes in front, becomes 1 over 2 times this 1 plus x. This very power becomes half minus 1. What's half minus 1? So you bring it down there like that. 1 times this here becomes negative 1 over. When your power is negative, what happens to your entire equation? It comes to the bottom. Or let's not forget, it comes to the bottom. Then this part here is negative. Comes to the bottom and everything else. That comes negative then. Negative there. This whole thing come at the bottom. So it becomes 1 there. So at this part here, you can get rid of this negative for the power here. Become 1 plus x, everything to the power, that there is going to be equals to half square root 1 plus x. F prime x is how you differentiate. I don't know whether you guys remember this differentiating. Yeah. Remember last time I told you the different ways of differentiating an equation. You can use this simple method of differentiating where the power comes there, power minus 1, what, and all that. Yes, and remember when your power is negative, how you can make it positive is it has to come to the bottom. Oh, sorry. It's still there. I just forgot to write it down there. The negative is still there. Yeah, negative is still there. Yes. Oh, by the way, this square root, everything is over 1. It's times like that. Yeah. So this is how you differentiate. So how we got that figure was by differentiating. We had to differentiate the equation we're given. There are times when maybe they can give you something that's way bigger. This is why you have to know how to differentiate. You should go through how to differentiate. Yeah. Because at times they can give you something that's more bigger than this simple equation they've given you here. Let's say, for example, let's see, what can they give you? Kaya, but whatever. Maybe at times, maybe they can give you something like with two different equations together. Yeah. Then there where you introduce the u, the v, and all that. Yeah. But just not to differentiate. Go through how to differentiate. But this is just how we got to that part there. That's how we got that. Yeah. So
that simply means we have started the suite.
what do you mean?
In line with what you said, we are doing with this question.
Yeah. Yeah, that's how you start.
I mean, you said we are starting this suite, isn't it?
Yes, yeah.
So we have started just that.
No, we're not done. This here is the beginning. Because we need to find our domain function. We need to differentiate our equation. Then from there, we now apply, now bring in the L. You now from there, bring in other things. You bring f of L. You have to not find if it's continue. You have to know if it's majore, if it's minore, if it's quaso, dequaso, all these things. You have to know all these things. So this right here is the starting point. It's how you start. Yeah. This is this. You first start by everything should be in function of x. That's the first thing. From there, find your domain function. After that, differentiate your equation. Then from there, use your domain function to now note down if what you found is quaso, dequaso, name it from there. Yeah. Then from there, what do? You now bring about one of the rules where we know that where our L is we're now bringing our L. We say L is going to be equals to the limit un. Yeah. And then from there we know that f is continuing. From our notes from last time, our notes, we thought f is continuing. We bring that down. You say when f is continuing, what happens? We know L is going to be equals to f of L. And then from there, what do? You go back to your initial equation. square root of 1 plus un. This one here, go back to this. Where there's un, you put the L. Where there's un, you're going to put the L there. And then from there, what do? It becomes L is going to be equals to square root of 1 plus L. Get rid of the square root. You have to do that there, that there. Now, that's now what I'm going to now do. So, everything we had done last week is now applied. This is now how you apply the things. Now, I'll show you guys. So, we found this, right? This was our equation after everything was differentiated. What's the next step? The next thing you have to do here is you have to now summarize or conclude from what you've been given, from the few things you know. From the few things we know that, okay, one of our domain functions which we're going to use is going to be this one here. We're going to use a 0 here. We use this one here. We use this domain function to conclude. Because this is practically the same thing. Noting that 0, because 0 is here a part of this thing. 0 is here a part of this domain function here. So we can still get this one here. So we'll get this one here. Just try and simplify things. Yeah. Because it's easier to have 0 and having -1 as your starting point, because at least 0 is more versatile, I should say. Yeah. So you get your 0, and then noting that already we know that our u0 here was greater or equals to 0, eh? Yes, yeah, that we already know. Yeah. So what you do is we'll now go and now say f prime x is greater. Yeah, f prime m is going to be greater than 0. That you know that there. And then since you know everything here is in function of x, so say for all x going to be a member of our domain function here, which is going to be 0, then the infinity open bracket like that there. Yeah. And then from here, from what we can just tell from this part here, even just from what, yeah, from this part here and from our main that we're given here, which is actually in our question, we can even just note that f is going to be croissant from there, croissant, continue, everything. Yeah. But then we already know that f is going to be continuing from our notes. That there we already taught from our notes. So we use that from our notes. Where are the notes we did last time? Are they here? Should we find that paper? Okay. Yes, yeah. Where is that part? Yeah. So remember last time we were looking at, like, when I had introduced this part here, right? When we're looking at the un plus 1 was equals to f of un there, then where n was greater or equals to 0, right? Have you seen this part here? This part here has been used in this case here. It was the u0 that was greater or equals to, the u0 was greater or equals to our 0 in our question. Yeah, and then like from our actual notes, we already noted that f was continuing. That we already knew from the notes we were given. Yeah, so we're going to apply the very same things that were done in the notes. Yeah, the very same things. Remember last time when I said that no, when f was continuing, what happens? Our limit was heading towards L. Our n was going to be L. So this here, we're going to apply that we know. So from our notes, we're going to come back. So say L is going to be equals to the limit that we already know. From our notes, we know the limit un, right? Remember where n is going to be heading towards L, because that there we already know, because we already know this from our notes. And then from there we know, we even know that f is continuing y from our notes that we already told. So this is why I was saying, all you do, you get your notes and you apply what the notes tell you. That's all you got to do. That's all. So you have your f there. We know f is where is that part? Okay, yeah. So you have your notes there. From the notes, that's what we're taught. The same thing. Then when you are able to notice, what do? That means now your entire function, because in this case here, our n is heading towards L, meaning L here is a limit. That means everything here will change from it being a function of x to it being a function of L, because now our limit has now changed to it being L. The notes talked about this. We had introduced L. The same thing here, introduced L. That's all. Yeah, and then from there, after you've done that, so it's now going to become, remember we said L is going to be equals to f of L. Why? Because the L is now the new limit. In this case, remember everything was a function of x. Now it should change to L. Why? Because now we're now looking at f being continuous. And how do you prove that you now bring about the L? You bring about your L. What's going to happen from here? So, because what's our f of x? Our f of x, remember our f of x was initially was square root of 1 plus x, right? Now in this case here, it's now f of L. What do you do? Where there's x, you put the L. So it's not going to become L. It's going to be equals to our f of L. In this case here, it's going to become square root of 1 plus L. Where there's x, you put your L. Then from here, what do you do? Simplify this here. So what's the next thing? Now say L is going to be equals to this whole thing is same as saying 1 plus L, everything the power half, right? There. Now what do? You have to get rid of this power here, right? Yeah, you have to get rid of this power here so you can find the value of L. What are we going to do from here? Okay. This here is the same thing. So as usual, what happens? To get rid of this square root, this power half, what you do? Multiply by 2, your power by 2. So he'll say power times 2 over 1. The same thing here, times 2 as you remember. Everything on the left, then on the right. Same thing, same rules. Same thing here. So what do you do? Here, it's now going to become L squared is going to become equals to, everything here will cancel. It become 1 plus L, isn't it? You now have that figure there. What do you do from here? Then from here, yeah. And then now after you have L squared is equals to 1 plus L, everything should come this other side. So we now have L squared. So say minus L minus 1. Yeah, minus L minus 1 going to become equals to 0. I'm sure you guys remember how to solve quadratic functions, right? What do you do from here? Here we know, remember that this L squared is A. This alone is just a single letter, whatever it is, single variable, whatever it is, it's B. Along there, C. What do you do from here? I have now find what? Yeah. Now, because just for us to summarize this very fast, we use that formula, negative B plus or minus square root of 4 AC minus B squared, yeah. No, sorry. Negative
B squared
plus or minus,
plus
yeah. B squared minus 4 AC, everything over 2A. You replace, you know what your B is, not your A is, not your C is. You replace here. When you replace in this equation here, then you now find your figures. Yeah. You find what L is. Remember, L was going to give you two different variables. Variables, numbers, or whatever it is. One will be positive, one's going to be negative. You're going to find your values there and everything else. Now, from here, we're now going to replace. Sure, I'll send the paper I'm using. Okay, so from here, what's that? Oh yeah, so delta is equals to B squared minus 4 AC, right? Yeah, so from there, we know what our B is. Our B here is negative 1. Negative 1 to the power 1 is what? It's still 1. Kazoom, no. Okay, anyway, it's okay, I'm using my phone. Yeah, going to become there 1 minus 4A plus C. The same thing, it's negative A, 1 there. Negative times negative 1, Yeah, times negative 1. Yeah, times negative 1 there. So our value here is going to give us 5. I mean, delta here is going to give us 5. Remember, delta is equals to B squared minus 4AC. Yeah. And then from there, you are going to have
Oh, you haven't placed your phone where we can't see.
Oh, sorry. Yeah, so delta is equals to b squared minus 4ac. Remember, the whole formula is negative b plus or minus square root of b squared minus 4ac, everything over 2a. Then this part here normally is noted here as delta. This is why here I put delta is equals to b squared minus 4ac. And you found this part here is going to give us 5. What's our b? Our b here is negative 1. Our b here is negative 1, that we already know. So, and but this, so the first thing we're going to have L1, whatever, have L1 going to be equals to, our b is negative 1. Negative 1 times negative is going to give us 1 plus square root of 5, everything over 2a. Yeah. Then what's the value of our a? Our a is 1, eh? Yeah, our a is 1. Yes, yeah. So this here is going to be for the first one. This is L1. Then your L2 will be the same thing. This time is going to be 1 minus square root of 5, everything over. Sorry, it's 2. It's 2 times 1, everything over 2. So you have your L1 and you have your L2. You solve that part there, right? Yeah. So you have your L1, you have your L2. We use this formula here to find it. So it's supposed to be like this. Yeah. Found out L1, found out L2. Hope you guys are following. Yeah. And then from here, the next thing is, after you introduce the L, what's our next step? What does, let's see, our notes, what do our notes say? Sorry, just hold on. Okay, so after all that, yeah, after we found our L1 and our L2, we found them there, found the values there for L1 and our L2. Yeah, and then from there, we're now going to have to summarize that. Yeah, we'll now summarize that as usual. We're going to say for ON is greater or equals to 0, and then the UN as usual should be greater or equals to 0. And then from there, yeah, just normally like what we do whenever when we look at, remember those other demonstrations we used to look at, the same rules here are going to apply. The same things, how you what do you call this? How you define them. You also have to define this part here as well. So we'll define that part and all that. Yes, gosh, guys, this question, normally when I ask you to study a suite, it's a very long question because you have to apply everything that you've been given here. Yeah, so after that, you now have to define everything that you've written down there. Remember at the beginning we didn't define our UN. This part wasn't defined, so we have to now define our UN. So first define our UN. I'm going to just say we have that for ON is going to be greater or equals to 0, and then we'll say our UN is greater or equals to 0, so which is literally the same thing. Yeah, and then from there, we're now going to look at it in 2 different probabilities, because here we have got two different answers, one negative, one here positive. We can end here, one here negative, one here positive, so we now have to solve it in different ways. The first thing I'm going to now say is, if our suite is greater or equals to 0, what's going to happen from there? We're now going to say it's going to be equivalent to UN plus 1. Remember our initial question is equals to square root of 1 plus UN there. This from our initial question there was greater or equals to 0. and giving this part here greater or equals to 0, greater or equals to 0, like that there. Yes, yeah, we have that there. Yes, yeah. Then now, after you've written down that there, this is the first part, greater or equals to that there. So because of that, we'll have to summarize. We'll say, donc L limit is equal to the limit of the switch UN there, and the switch UN there, where n is going to be approaching L like that there, which is actually going to give us which one here. So among L1 and L2, which one of the two here like defines this first probability where UN is greater or equals to 0? It's going to be this first one here with the positive sign, because when you solve these, you're finding a positive answer, and this is the only answer that actually goes with this definition here. So it's going to be equals to L1, which is equals to 1 plus square root of 5 over 2. Yeah. So we've done the first probability is this one here, which we've actually done. Yeah. Oh my goodness. Yeah. And then we're now going to suppose that now this whole thing here is going to now be equals to, that they'll be equals to alpha there. Well, we've just supposed, we've just said, no, this is equals to this. Don't ask me where the alphas come from. We are supposed, you can put alpha, beta, gamma, I don't know, whatever it is you want to put. Yeah. Sorry, I can't see the people wait. Oh, hold on, just give me a second. Okay. Yeah, so from there we'll just suppose that the 1 plus square root of 5 over 2 is going to be equals to alpha there. Yeah. And then now we're not going to look at it the other way. Now we'll now say, since we've already shown that 1 should be greater or equals to 0, now the opposite should be less or equals to 0. The same thing we did there, you have to apply the same rules again. Yes, yeah. Do the same thing there and all that. Yeah. Yes, yeah, let me see. Hold on. Yeah, anyway, so there, the same way we had to prove, just hold on, give me a second. Yeah, so after we find that, sorry, pardon my bad manners, just yawning anyhow. Yeah, so after we find that, since we've shown the first probability, if it's greater or equals to 0, now I have to now show the opposite probability that exists, which it does exist and it's there. I know that, yeah. And then after you do that, there's some other processes there and all that. Then the whole point of this part was just for you guys to see how you apply your notes. You see how we applied one of the first points there we were given. What's not first point, second, third point were given there, which is basically when they introduced the L. And you've been looking at this for a very long time, where we know that the switch UN has a limit, which is, sorry, which last part do you want me to re-explain? Huh?
Yo inevera patiara sia opening mama.
What I wrote?
Yeah.
Okay. So we found our L1 and our L2, isn't it? Yeah. And then from there, since just by definition, we know that initially our suite is in function of A and M. So, and then our question was given that the U0 was greater or equals to, so the U0 was greater or equals to 0. Yeah, it was greater or equals to 0. And the U0 is basically like our domain. Yeah. So there, that's how we first had to, the first thing we said was that we have, for all n is greater or equals to 0, right? Then we also noted that the suite UN was greater or equals to 0 as well. Yeah. And then from there, we say we had to, since we have two answers, one is negative, one is positive. We have L1 and we have L2. Yeah. Then the first thing we now said is if our suite is greater or equals to 0, that means here you're looking at the positive answer you found. I don't know whether you guys can hear me now or not.
Again.
Okay. Yeah, so the same application as I said last time on Tuesday was that you get the notes. The very points we're looking at are the same thing that I did here. Introduce the L and introduce the L. We've been talking about L and the suite UN. The same thing here was applied on how we solved it and everything else. Yeah. The question does go on to refine this and everything else. Yes, yeah. But my network right now is really bad, so I don't know if you guys are going to be able to get me properly. Yes, yeah. And the main phone, but that's okay. Yeah. So the way I went and I started by saying if the first thing I said was when it's positive greater or equals to 0, that's the first approach I went from. You have to now prove or rather summarize or show us now why what you've been given is going, why what you've been given, what why what you've been given is either going to become croissant, decroissant, and all that. Yeah. So what we're going to do is that I'm going to give you guys a question, just one question, a very simple question. The same thing we've done, the very same thing we've done here. The steps I did and all that, I'm going to send you guys I'll send you guys a paper how I solved everything. I want you guys to apply. I want you guys to apply the same things the same things we solved here on the question. And you guys, please, this time, for crying out loud, at least I beg you guys, try and solve the question so that at least you are familiar with how to do it. Yeah, this time I've done it. So this time I'm sure, or I hope you guys will be able to solve the question this time around. So the same things the same things we did here, the same things they're going to apply. Yes, yeah. So I'll send you guys 2 questions here, 2 questions instead. There are 2 questions. They're very easy questions, straightforward, same application, the same application, same thing, same way you apply the same thing. Yeah. Here's why I tell you guys, you have to make sure you read the notes, because the notes is how I actually went about and solved this thing. Except I didn't go and show that it was croissant and everything. It's like the final solution. I'll continue and I'll solve the final solution, and I'll send it to you guys. Yeah. Otherwise, the last part is very simple. It's just reading and just knowing. You guys have been reading. I've been explaining to you guys so many different demonstrations on how, why, this is this, and this is that for a very long time. When we look at the PDF, I've been saying so many things on that part. The same thing I'm just going to write down on the paper. And I'll send it to you guys. And I'm done. I think it'll give me just like a good 5 minutes or so. I'll send it to you guys. Yeah. And also 2 questions. You guys should solve the questions on Tuesday, 15 hours. Someone is going to, actually, no, from all of you guys, 2 people, 2 or 3, I don't know, 2 or 3, 4 of you on Tuesday, you're going to come and you're going to explain to us how you solved whatever it is you solved. Whatever it is you solved, yes, yeah. Yeah. So on Tuesday, you guys should not send any to me, no. I'll send you guys a question so you can solve on your own. Yeah. So whether you attempt or don't attempt to solve it, it's going to be your own baby junior, it's not mine. Yeah. But I would advise you guys to try and actually attempt to solve the question so that at least you can make things easier for you guys to understand and all that, so that even it's easier for you guys to apply. Because what happens is, the best thing is for you to actually attempt to do something, because come Monday, I'll pick at random. So you guys should just try and you solve the questions. And Monday comes, you explain to us. There's no Moono R, no Moono this, no Moono R. Nah, you guys know. You guys have to do this thing for yourself and for nobody else. It's for you guys. Yeah. So make sure you solve the 2 questions. I'll continue solving the other part. It's not even solving the other part. What's left? Just have the summary. I'll do the summary. So come Tuesday, you guys, you should make sure you guys do the work and all that. No, there's no deadline. There's no deadline. Just for that. Yeah. So that's that. Otherwise, I'll send you guys everything and have a good evening and take care of yourselves. And yeah.
Oh, wait a minute.
Oh yeah.
Does it mean the coup is over?
Which coup? Huh?
This one which we are currently having.
Oh, this one?
Yes.
Oh yeah. You want me to go on?
Oh. No, since I saw like closing remarks, so I was a bit confused because we didn't finish the question. So
Oh, did you hear what I said?
I was still processing what's happening.
Oh, I said for the question. For the question, there's only a small part that's left, and I'm going to send you guys the solution on the last part. Yes. I'll send you guys the solution for the last part. Actually, it's just more of a summary. The last part, yeah. So I'll send you guys the paper, yeah, FOO and everything else, yeah. And I'll send 2 questions which you're supposed to solve on your own. Don't send me your solutions, no. But on Tuesday you come and share your solutions to all of us. Yeah. Yeah. And it will be very brief, very fast, so that we can do other things as well. Yeah. Because we have to start looking at something else. Come Tuesday. So Tuesday we're going to conclude on sweets when you guys solve these questions, these 2 questions, and everything else. Yeah. So that's that. Yeah. Is there any question?
Another question before I close.
Yeah.
So these same 2 questions, while we get stuck, we can ask you.
Huh?
These same 2 questions that you sent to us, while we get stuck, we can send to you, or we can ask you for some help.
Yeah, you can. But as I say, don't text me, call me, because if you text me, I won't. At times, I don't see your I don't see text. Just call me. At least I'll respond to you faster if you call me. Don't text me. I don't know when I'm going to respond. I'll forget.
Oh, okay.
Yeah. So that's that. Any more questions? Any other questions?
Video call audio.
No more questions?